In discussing what is beauty, the first thing we need to do is distinguish between beauty and taste. For example, in an episode of the Young People's Concerts, Leonard Bernstein turns to the audience after playing a movement of Mozart's 40th Symphony and says, "Whether you liked that or not, that was beautiful." And he's distinguishing there between taste and beauty. That was a beautiful thing whether or not you had a taste for it. You see, taste is what you like. It's what you've been conditioned to like by your experience. Beauty, on the other hand, is objective, and it's determined by simplicity, harmony, and brilliance. These are the three aspects that we'll talk about a little bit later. But the fact is, it takes time to see things that are really, truly beautiful. It takes time to know what to look for and how to experience it. For example, people who are able to appreciate good wine, classical music, gourmet food, physics, the way that scientists and mathematicians talk about the beauty and science and math, poetry, it takes time to learn about these things before you can appreciate just how beautiful they are. Some of these I've had experience with myself, and some I'm trusting what I've heard from experts in these topics. The fact is, some things get better the more you learn about them, and there are some things that get worse the more that you learn about them. The things that are really truly beautiful are the things that get better the more you learn about them. For example, this is from a course on listening to great music by Robert Greenberg, and he's just described someone who is at a baseball game, who's never been to a baseball game before, knows nothing about it, and there's this great play that takes place. But without knowing the large-scale context, without knowing about the game, you can't appreciate the beauty of that play in baseball. And he says this, "A great truth has just been revealed. Without a large-scale structural context, detail cannot be contextualized. Without an understanding of how something works on the large scale, we might not perceive the details that make something interesting. We can only appreciate that detail if we first understand the large-scale context, the rules of the game, the form of the piece." And this is the course from which we get that quote. Professor Charles Balin is a astrophysics professor at Yale, and you can see this course on iTunes U. And after telling a story of beauty to his graduate physics class, a story of beauty from a graduate physics class that he was in, he says to his class, "So don't be condescending to the physics majors who are up late on a Thursday night working on problem sets, because they have access to realms of aesthetic experience that you can only dream of." And he says it takes time to get there. Plato, quoting a proverb, said, "Fine things are hard." And that word fine can also be translated as beautiful. So what is beauty? Simplicity is the first aspect of beauty. Heisenberg refers to it as frightening simplicity and wholeness. The idea is that disconnected ideas do not form beauty. There has to be some connection, something that somehow makes the thing one. There's a sense of oneness. And I've heard this also described as unity. Another part of it is harmony. That's the other aspect. And Heisenberg, the physicist, talks about this as the proper conformity of the parts to one another and to the whole. John Wheeler, another physicist, says that every law of physics goes back to some symmetry of nature. This idea that things are related to each other in just the right way. We have this innate sense of that. Without harmony, there's no unity. I've also heard this referred to as balance. And then brilliance. This is the third aspect of beauty that I find hardest to describe. I've also heard it called clarity. I've heard people refer to it as a fitting surprise. It's finding these fitting surprises where a theory of physics is discovered and they think to themselves, of course, it had to be that way. There's a sense of recognition about it. It allows for insight, intelligibility. Somehow we get it. We see it and we know it. And I think that we experience that as recognition, like when we see someone out of context, like you're at the mall or something, and you see someone that you know, there's this sense of recognition. That's an aesthetic experience. Or like when we get a joke, that's an aesthetic experience. I've heard it referred to by an artist as a sense of innate inevitability, that it had to be that way. Leonard Bernstein talks about this innate inevitability with respect to Beethoven's music, that we recognize, of course, that's the way it had to be. For example, here's Leonard Bernstein talking about it. Many composers have been able to write heavenly tunes and respectable fugues. Some composers can orchestrate the C major scale so that it sounds like a masterpiece, or fool with notes so that a harmonic novelty is achieved. But this is all mere dust, nothing compared to the magic ingredients sought by them all, the inexplicable ability to know what the next note has to be. And that's that sense of inevitability. Beethoven had this gift and degree that leaves them all panting in the rear guard. When he really did it, as in the funeral march of the Eroica, he produced an entity that always seems to me to have been previously written in heaven, and then merely dictated to him. Not that the dictation was easily achieved. We know with what agonies he paid for the special space carved out in the cosmos into which this movement just fits, predetermined and perfect. So there's that sense of brilliance, of inevitability. It had to be that way somehow. And talking about beautiful experiments, too, George Johnson writes this: "These experiments were designed and conducted with such a straightforward elegance that they deserve to be called beautiful. This is beauty in the classical sense. The logical simplicity of the apparatus," so there's our first aspect, right? Simplicity. "Like the logical simplicity of the analysis, seems as pure and inevitable," his words, not mine, the inevitability, right, "as the lines of a Greek statue. Confusion and ambiguity are momentarily swept aside, and something new about nature leaps into view." George Stanciu is a physicist, and he's relating this experience that he had of beauty. He says, "In the 10th grade, I was forever changed by Euclid's proof that the prime numbers are infinite, an exquisite proof that surprisingly showed in 6 lines of text an eternal truth. Until that point in my life, I thought truth did not exist. Everything about me changed, the seasons, my body, and people. My experience of the human world was that everything was in flux, sometimes bordering on the absurd. Suddenly, mathematics presented me with one thing that was unchanging, a timeless truth demonstrated in an exceedingly beautiful way. The 2,500 years between Euclid and me were of no consequence. My encounter with Euclid was not unique." Bertrand Russell described his first encounter with serious mathematics. So we have George Stanciu's experience of beauty, and here's another one from Bertrand Russell. "At the age of 11, I began Euclid, with my brother as my tutor. This was one of the great events of my life, as dazzling as first love. I had not imagined there was anything so delicious in the world." Another story from this same physicist, George Stanciu. "During the summer before my senior year at the University of Michigan, I took Introduction to Theoretical Physics, taught by Professor Otto Laporte. For some odd reason, the class met at 7 p.m. One night, Laporte walked in with 2 martinis under his belt and announced, 'Tonight, gentlemen, I'm going to show you something beautiful.' He proceeded to elegantly lay out several fundamental theorems about vector spaces. When finished, he stepped back from the blackboard and said, 'Isn't that beautiful?' One student in the class, the very worst one, asked, 'What is so beautiful about that?' Laporte was taken aback, and after a moment of silence asked, 'Do the rest of you see that this is beautiful?' We all nodded, and several students replied, 'Of course.' The professor then turned to the student who was blind to the beauty of vector spaces and told him, 'You be quiet, the rest of us see it.' So I'm trying to point out these examples of people seeing beauty and these tying together these 3 aspects of beauty. Here's another one from a book about ancient Greece by H.D.F. Kiddo. But he talks about this beauty that he discovers in mathematics, in a really sort of simple mathematical operation. He says, "It occurred to me to wonder what was the difference between the square of a number and the product of its next door neighbors. 10 times 10 proved to be 100. 11 times 99, 1 less. It was interesting to find the difference between 6 and 6 and 7 times 5 was just the same. And with growing excitement I discovered, and algebraically proved, the law that this product must always be 1 less than the square. The next step was to consider the behaviors of next door neighbors but one, and it was with great delight that I disclosed to myself a whole system of numerical behavior of which my mathematical teachers had left me, I'm glad to say, in complete ignorance. With increasing wonder, I worked out the series. 10 times 10 is 100, 9 times 11 is 99, 8 times 12 is 96, 7 times 13 is 91, and found that the differences were successively 1, 3, 5, 7, the odd number series. Even more marvelous was the discovery that if each successive product is subtracted from the original 100, there is produced a series 1, 4, 9, 16. They had never told me, and I had never suspected, that numbers, notice that he capitalizes numbers here, play these grave and beautiful games with each other from everlasting to everlasting, independently, apparently, of time, space, and the human mind. It was an impressive peep into a new and perfect universe." Professor Charles Balin tells this story in this course, where he says that he was in a class and the professor was writing stuff on the board, and he was furiously copying it down until he realized what was happening. He was going to prove Chandrasekhar's limit, which has to do with black holes and the size of stars and that kind of thing. So he said he just wrote Chandra on his paper and he put his pen down and he just watched. And he said it was incredible. The only thing he can compare it to is a piece of music because it unfolds in time. And he points out these aspects of beauty, the way it ties together, this sense of unity about it, and this inevitability. And so I hope that you've enjoyed this video and learned a little bit about the way that philosophers and physicists and mathematicians and musicians think about beauty and these three aspects: simplicity, harmony, and brilliance.